Okay, so now that we've had a quick review of how to graph on the coordinate plane, I want to get to the main topic of this next lesson, and that is going to be the concept of a relation. There's going to be a bit of vocabulary in this next part, so anything I don't jot down that you hear me say might be a good idea to jot that down as well. So a relation. We're going to be talking about this concept a lot here in the coming weeks, but the basic definition of a relation is it's just a set of ordered pairs. Okay, a relation is just a set of ordered pairs. And today we're just going to talk about different ways you can represent relations. One way to represent a relation is using what's called a mapping diagram, or sometimes we just call this a mapping. So down here in this example, you can see what a mapping diagram looks like. It's basically just one column of x values and then another column of y values. Okay, and from each x value, you see an arrow drawn to another y value. Okay, so this relation is showing that 2 maps to 1, the x value of 3 maps to the y value 1.5, the x value of 4 maps to the y value of 2, etc. And so what I want you to think about in this relation is what's the relationship between these input values, that would be the x values, and these output values, that would be the y values. Okay, the x values are what are called our input values, and the y values are what are called our output values. Pause the video, think about that for a second, and then click play when you're done. Okay, so the relationship between each of these input values and these output values is, hopefully you can see, each output value is half of the input value. Okay, so we could say to get the output, you divide the input by 2. 2 divided by 2 is 1. 3 divided by 2 is 1.5. 4 divided by 2 is 2. 5 divided by 2 is 2.5. 6 divided by 2 is 3. Okay, so that's the relationship going on there. But again, this is just a good representation of a relation, a set of ordered pairs of input and output values. Okay, down here in examples 7 and 8, we have two other relations in the form of mapping diagrams. These relations aren't necessarily ordered pairs how we think of them. Okay, they aren't numbered ordered pairs. They're words and numbers mixed, but it still gives you the same concept. So look at example, this is supposed to be example 7. In the input column, the x column, I have different people's first names, and in the output column, the y column, I have numbers. So I have Billy going to the number 5, Christina going to the number 9. And what I'd like you to do now is just take a second and think, how do each of these input values, each of these x values relate to each of these y values? Okay, think for a second why each of these x values is going toward each of these y values. And hopefully you saw this. If you didn't, that's okay. If you notice, Billy has 5 letters in his name, B-I, 2 L's and a Y. He's going to 5. Christina has 9 letters in her name. She's going to 9. Drew has 4 letters. Kelsey has 6. And Larry has 5. So each output value corresponds with the number of letters in each input. Okay, each output, again, those are the y values, corresponds with the number of letters in the input. So that's the relation going on here in this mapping diagram. Take a look at number 3. We have another mapping diagram. We have different fruits in the input column and different colors in the output column. Take a second, think about what the relationship in these values might be. And this one I think is a little bit easier. Each fruit goes to the color that you'll often find that fruit to be in. So apples, you can find green apples, red apples, and yellow apples. I have yet to see a blue apple. Bananas are typically yellow. Blueberries, blue. Raspberries, red. And strawberries, red. So we could say the relationship here is each output corresponds to the color of each input. Okay, so again, what I want you to take away from this is these are just other examples of relations, okay? A set of input values and a set of output values, or a set of ordered pairs, okay? These are also examples of relations. So moving on to a little bit more math behind this. When we talk about relations, we often refer to a set of input or x values, as I was talking about, and this is often called the domain. Okay, so that's a really important vocabulary word to know. The set of input values or the set of x values, okay, each of those values in that first column in each of these mapping diagrams, we often refer to that set of values as the domain. And then the set of output or y values is often referred to as the range. Those are two vocab words that we're going to be using over and over again from now until forever. So you need to get used to both of those words right there. Domain refers to the x values and range refers to the y values. Okay, last thing I want to talk about in this video is how we can represent relations. Relations can be represented in multiple ways. One way is by using a mapping. That's what we did in the last few examples. Another way is by using a table. And then finally, we can use a graph. So now we're going to practice representing relations, okay, going back to just regular ordered pairs, using each of these three methods, a mapping diagram, a table, and a graph. So for number 9, I have a set of 4 ordered pairs. I have 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. And I'm going to represent those ordered pairs using each of these three methods. I'm going to start with a table. So a table just looks like this. Okay, it's going to be 2 columns, one column of x's, one column of y's. Sometimes they call this a t-chart. And what we're going to do is we're just going to put each of the x values in the table. So our first x value on this ordered pair is 2. So I have 2, then I have negative 2, then I have 5, then I have negative 1. Okay, those are each of my x values, 2, negative 2, 5, and negative 1. And then in the other column, I'm going to put their corresponding y values. So this 2 corresponds to this 5. This negative 2 corresponds to this 3. This 5 to this negative 2. And this negative 1 to this negative 2. Okay, so that's how I make a table of my x and y values. Now I'm going to make a mapping diagram using those x and those y values. Okay, so a mapping diagram, it's going to look a little bit similar to a table, except we're going to use arrows, okay, to show the what each x value, which y value each x value corresponds to. And when I make my mapping diagram, typically I put my values in order. So for my x values, I'm going to start with the smallest x value, which is negative 2. Okay, and then I'll do negative 1, 2, and then 5. So typically we go least to greatest when we do a mapping diagram with the x values, and then we do the y values as well. So I start with my smallest value, which is negative 2. Notice I have a negative 2 twice in my y value column. I'm not going to list that twice, though, when I do my mapping. Okay, I'm only going to list it once, so I'm just going to put the negative 2 one time, and then my next number is 3, and then my next number is 5. So now what I'm going to do is I'm just going to draw arrows from the x values to the y values. My first ordered pair was 2, 5, so I'm going to go from positive 2 to positive 5 here, and that just shows that 2 corresponds with 5. My next ordered pair was negative 2, 3, so I'm going to draw an arrow from negative 2 in my x column to 3 in my y column. Then I had 5, negative 2, so 5 to negative 2, and then lastly negative 1, negative 2, so an arrow from negative 1 to negative 2. Okay, so that would be how I can represent these ordered pairs, this relation using a mapping diagram. The last thing I'm going to do is I'm going to represent this relation using a graph. And so now I'm just going to plot each of these ordered pairs, starting with 2, 5. If I start at the origin, that's right 2 and up 5. there's 2, 5. Then negative 2, 3 would be left 2 and up 3. 5, negative 2 would be right 5 and down 2. And negative 1, negative 2 would be left 1 and down 2. Okay, so 3 different ways, a table, a mapping diagram, and a graph to represent the same relation of 4 ordered pairs. Okay, number 10, we're going to do the same thing. What I want you to do is pause the video on your own, try each of those 3 representations, the table, the mapping, and the graph, and then once you get all of those, click play to check your answer. Okay, here you can see all 3 of these representations. My table, 3, negative 4, 0, 3, 2, 4, negative 1, negative 4, negative 3, 0, my 5 ordered pairs. Here you can see my mapping diagram. If I have 5 ordered pairs, I should have 5 arrows drawn, which I do. 1, 2, 3, 4, 5. And then finally, my graph. If I have 5 ordered pairs, then I should have 5 points on my graph. Okay, last 2 examples. We're going to actually go back to the examples we just did, and we're just going to determine the domain and the range of each of those examples. Okay, so let's go back to example 9 and talk about what the domain of that example is. Domain, again, just refers to the x values, okay, or the input values of a relation. So if I look at my table or my mapping, either one, I can see that my x values are negative 2, negative 1, 2, 5. Okay, it's these values right here. Those are your domain values. So when you're listing a set of domain values, all you're going to do is you're going to list those numbers in what we call braces. That would be the squiggly lines that none of you like to make. Too bad. We're going to list those values in a set of braces. And when we list domain values, we just list them in order and we don't repeat. So just like we do on a mapping diagram. List them in order, least to greatest, and we don't repeat. So those domain values, again, are negative 2, negative 1, 2, and 5. And again, those are my x values. Your range values are the y values. So going back to example 9, those range values would be these values right here, negative 2, 3, and 5. Okay, example 10, your domain values, again, those are the x values, are the values in your first column. So those would be negative 3, negative 1, 0, 2, and 3. Your range values are negative 4, 0, 3, and 4. Okay, any questions you had over this or just the review of our graphing, please be sure to jot those down. And until I see you again, have a nice day. You're all wonderful, wonderful people.